Okay, so in this diagram here, we're going to have another episode of how do we wire it. So if we look on our screen right now, what we have is a breakdown of a gas furnace, just minus the ignition components to it, like your ignition modules, maybe your standing pilot, stuff like that. But we're just focusing on the very basic components that are found on your typical gas furnace. So up here in the left-hand corner, we have our power source. Here's our switch, our L1 and our neutral. We have an emergency switch, which is at the top of the stairs. We have a fan relay. This is going to be commonly found on air conditioning and gas heat furnaces, which will change the blower speed based off of whether we're in heat or in air conditioning. And obviously, as we go through this, I will explain that to you in a little bit more in depth. We have our fan and limit switch, our normally closed, which is our limit side. Our normally open is our fan side. We got a transformer, blower motor, thermostat, and a 24-volt gas valve. Okay, so let's get started. So what do we do when it comes to anything that is regards to wiring? Well, we know that most of our circuits in HVAC are going to have line voltage. They're going to have a 24-volt circuit, which is our control voltage. Okay, so anytime I like to wire anything, is I always focus on my line voltage stuff first. What is going to be receiving my 120 volts? What's going to be receiving 208, 230, whatever it is that I'm working on. Okay, for the sake of this is 120 volts. We have L1 and neutral. So where do I begin? Well, right at the very top. Okay, so we got L1. I have an emergency switch. I have a transformer. I have a 120 volt primary, 24 volt secondary. I have a blower motor. Blower motor is going to be receiving 120 volts because it's a load. I got to use it to blow air across my heat exchanger so I can deliver heat to the space. I also have my relay and my fan limit switch. Those are really all of my components that are going to be on the 120 volt side of stuff. So let's get going. So we have L1. Usually when this is wired, we have L1. This is going to be my breaker. That's going to be in my panel. Coming out of my panel, I'm now going to come down into my, sorry, I got to change my pad here. Here we go. I'm going to come in. I'm going to come down into my emergency switch, just like this. Okay, there's my emergency switch. Okay, after my emergency switch, I think I'm actually just going to change it. Let's go with a straight line. How's that? Let's erase that. Let's start over because I like things that are nice and neat. Okay, so let's just erase this. Erase that. Okay, let's go with a nice straight line. So again, we're coming here. I got my L1 going down into my emergency switch. Out of my emergency switch, I got to go in a couple different directions. Okay. The biggest one is we know that I have a transformer. My transformer needs to be powered on my 120 volt side, my primary side. Okay, so I'm going to do that. I'm going to power that up. Okay. Out of that, I'm going to let's go with blue. Right? We'll go with on my neutral side or my common. Right? That's going to come up, and I'm going to come right back to my neutral. Okay. Remember, on any circuit that is out there. We got to have a source, a switch, a path, and a load. We have already just have that one basic circuit right there. Okay, here's my source, my path, here's my switch, and the primary side of my transformer is my load. Okay, so where else do I need to go to finish my 120 volt side of this diagram? Well, just like I've said before, we have our fan relay, we have a fan and limit switch, we have a blower. Those are all 120. So this is a standard Mars relay. That standard Mars relay, we have terminals 1, terminal 2, which is our normally open, terminal 1, terminal 3, which is our normally closed. Just like I said before, this type of relay is going to be found when we have a furnace that has both air conditioning and gas heat. Okay, because I want to be able to change my fan speed from low speed to high speed so that I can either slow down the air movement across my furnace or speed it up based off of whatever mode I'm in. So I'm going to go there. I'm going to come up and I'm going to power up my terminal 1, because usually on a Mars relay, terminal 1 is your power coming in to that relay. Your terminal 2 and terminal 3 are your throws. Okay, it's going to send power out to where I want it to go. So, in gas heat, I don't want my blower to be on a high speed. The reason why I don't ever want my blower to be in high speed in gas heat is because if I move it too fast across my hot heat exchanger, I'm going to cool the air off too quickly. It's moving too fast. I'm not going to be able to achieve my temperatures that I want to be coming out of my supply ducts. Okay, usually we want somewhere maybe like 120, maybe 130 degree air coming out of there. Okay, again, it depends on manufacturer specifications. So I want my fan to be in low speed. Okay, so when we are in heat, this relay is just sitting there. It's dormant. It's not moving. Nothing's changed. My contacts are going to be as we see them on this picture. Okay, our terminal 1, terminal 2 are going to be open. Our terminal 1 and terminal 3 are going to be closed. It just sits there. So I'm coming out of my terminal 3 for this particular diagram. And what I'm going to do is I'm coming out of terminal 3, and I'm going to come right down to my fan side of my fan limit switch. Because I want my fan limit switch to turn my blower on when my furnace gets hot enough. Okay, so really other ways you kind of think about it. That Mars relay that we see here is just a component that's just in the system at this point. It's not doing a damn thing. It's just sitting there. All I'm doing is just passing it through. Because all we're doing is we're utilizing that relay in the air conditioning mode. It's just there. Okay? So as I come out of that relay, I'm going to come into my fan limit switch on my normally open. Okay? Because at 150 degrees or 140 degrees, this switch is now going to close. And when it closes, it is now going to energize the low speed of my blower. Okay? Again, I'm just going to come here. We're going to use blue. Okay? My blue. I'm just going to go right back to my neutral. So then, there is my source. Here's my source, my switch. In fact, we have a switch here and a switch here. My path, another switch, and a load. which will now energize my blower when we are now in the heating mode. Okay. Now, someone may ask, how come I didn't wire in the other side of my fan limit switch? Well, you have to understand that a fan and limit switch are two switches that are wired in parallel. One is going to be used to turn my blower on at a specific temperature, like in this case maybe 140, maybe 150 degrees, somewhere in there. And then the other side of that is a limit. It's a safety. I want my furnace to shut off in the event that my furnace gets too hot, for whatever reason that may be. Dirty filter, bad blower motor, blocked ductwork, closed dampers, whatever. Okay? We want it to shut off because it now becomes a fire hazard. We don't want that. We want to be able to protect stuff. Okay? So now, what do I do for the rest of this? Oh my God. Well, I have my secondary side of my transformer. I have a coil. I have a normally closed set of contacts. I have a gas valve and a thermostat. So what do I do to get this guy to complete my circuit and make this guy work the way I want? Well, we're going to now focus on the 24 volt side. We have pretty much completed the line voltage side of our circuit so far. I haven't done number 2 because I'm going to explain that in a second as to why I didn't do number 2 on my relay. Okay, so we're going to focus right here on our 24 volt side of our transformer. Our 24 volt transformer is what's going to be supplying that 24 volts down to my thermostat. So I got to power that up with my red wire. Remember, red on a thermostat is my power. Just like that. There's my power. Okay, my thermostat, I have W, I got Y, and I got G. Okay, so what am I doing with this? Now remember what I was saying. This is a diagram that has both air conditioning and gas in it. So don't let that confuse you. We are going to explain this as best as we possibly can. So now we have a W. What is W terminal on a thermostat? The W terminal on a thermostat is your heat. So I got to have my power, and I'm going to use a different shade of white. Well, I can't use white because usually that's what it's going to be when we're on a thermostat. It's going to be a white colored wire coming out of your W. So we're going to use a different shade. Let's use, I guess I'm going to use this darker red. Okay, so out of my W, I'm going to come out of my W. I'm going to come up to my limit side of my fan limit switch, because remember, guys, that's a limit. If my furnace gets too hot, probably around 200 degrees, I want my furnace to shut off. But what am I controlling? What do I want to shut off? Do I want my blower to shut off? Do I want it to kill my transformer? Do I want it to kill the gas valve? What do I want it to kill? In most cases, what you're going to wind up seeing is your fan limit switch, the limit side of this, is going to take out and de-energize the gas valve. So I'm going to come out of my limit, and I'm going to come down to my gas valve. Just like that. Okay? Out of my gas valve, we're going to use, again, a different shade of blue. Okay? Out of my gas valve, I'm just going to come up and complete that circuit. Go right back to my transformer, my common side of my transformer, just like that. Okay? That's my safety circuit right there. So in the event that this guy opens, my gas valve will get de-energized. And when the gas valve is de-energized, it closes. It shuts off the gas flow to my burners. I won't have any more fire in my heat exchanger at that point. Okay? So what do I do with the rest of this? I still have my coil. I have my terminal 2, and I have my high side, or my high speed of my blower. So when we are in air conditioning, just a little tidbit for your air conditioning side of stuff. You will see down here on your thermostat that you have terminals Y and G. Y is our air conditioning, G is our fan. A majority of your thermostats that are out there in the field, Y and G are internally jumped inside that thermostat. So what does that mean? Well, it means when our fan switch is in the auto position, as you can see here, that G terminal will get energized when my Y calls for air conditioning. So in other words, here's my power. Power is coming in to my R. When I flip my switch from my heat to my cool, I am now completing the circuit here. My thermostat will close, calling for cooling, which will now send my power out to my compressor and my condenser fan motor to bring on my cooling. But I am also energizing my G terminal. My G terminal will also get powered. So what I'm going to do here is I'm going to utilize my G for this diagram. And we're going to use green, obviously. So I'm coming out of my G, and I'm going to come right up to my coil. Because remember, I want my fan to change speed when I'm in air conditioning. I want it to go from low speed to high speed. It's crazy, isn't it? But in reality, it's really not. It's just a simple manipulation of the circuit. So if I was in air conditioning, this guy would close. I'm not going to put a Y here because I don't have anything on this diagram to show you what the cooling side of it would be, because I don't want to confuse anybody. So what we're doing here is we're just showing you how the fan changes from low speed to high speed based off of whether we are in heat or we are in air conditioning. So my G, if this guy was to close, I would again send it out to my condenser coil outside, my condenser fan motor, so I can start beginning to have some air conditioning. My G would also get energized at the exact same time. So when I do that, I'm energizing my coil on my little relay. So when I energize that coil, what's going to happen with the contacts? They're going to change position. My normally close is going to open. My normally open is now going to close. So where do you think terminal 2 goes on my relay? It goes down to my high speed on my blower. But let's finish that coil first. Where does it come to after I power it up? Where does it go back to? It's very simple, guys. It goes right back to the transformer on my 24-volt side. Just like this. Boom. There's my circuit. My G, comes up, energizes my coil, finishes it, and goes right back to my transformer. Again, source, path, switch, load. So to finish it up, I'm just going to use black again just to finish it. Or actually, you know what? I'm going to change that color. Let's go with, we'll go with orange or something like that. So terminal 2 comes out. It's going to come down. I'm just going to go this way. Just kind of make it a little easier so you can see it. And I'm going to go right into my high speed. So what's the sequence of operation here? We've completed wiring it. It's done. So what's the sequence of operation here? Well, obviously, first we have to make sure that the breaker is on. We have to make sure that the emergency switch at the top of the stairs is on, because a lot of people like to mistake that for a light switch and accidentally shut it off in the dead of winter. It does happen. We have to make sure that the emergency switch is actually on and in the closed position. So what is going on here? I'm sending power out to my relay, my transformer, and through my fan side of my fan limit switch so that I can energize the low speed of my blower. So at a call for heat, when the temperature drops inside the space or in the home, my switch here closes, which will now send a call through my limit side of my fan limit switch down to my gas valve, which will energize, which will obviously ignite the gas so that we can have heat. Once I have established a flame in the furnace, the temperature begins to rise. Once the furnace reaches a temperature of somewhere maybe between 140 and 150 degrees, my fan side of my fan limit switch will now close. And when it closes, my low speed of my blower will now turn on. And I will now start to circulate the air through the furnace so that I can now start delivering heat to the space. Now, in regards to the air conditioning side of this, if I was in air conditioning, my Y would close, calling for heat, which again will turn on my outdoor unit, my condenser and condenser fan motor. But it will also energize my G, my fan. And when that happens, I'm sending power up to that relay, which will then energize, which will now change the contacts on my relay, which will now switch my fan speed from my low speed to my high speed. What I want you to see in this diagram is you have to notice that my terminal 3 is being controlled by my fan limit switch, which is my low speed. My terminal 2 is directly wired to my high speed. My fan limit switch is completely bypassed when I am in the air conditioning mode because I don't need it when I'm in air conditioning. And that's how you wire a gas furnace with air conditioning.